Welcome back to Maths in an Empty Classroom with me, Mr. Southern. This is part 2 of the lesson on hypothesis testing using the normal distribution. And in this video, I'm going to be talking about how to find a critical region for a hypothesis test on the normal distribution. So this example again is taken from the Pearson Edexcel Year 2 Pure textbook. Thank you very much to them. And here we go. So we have a machine produces bolts of diameter D, where D has a normal distribution with mean 0.580 and standard deviation 0.015. So straight away, I'm going to jot down that D, the population, follows a normal distribution with a mean of 0.58 and a standard deviation of 0.015. But as discussed in the previous video, I'm going to write 0.015 squared to demonstrate, to show the variance here. The machine is serviced, and after the service, a random sample of 50 bolts, which is telling me that N equals 50, that's important, from the next production run is taken to see if the mean diameter of the bolts has changed from 0.580 centimetres. I'm just going to underline that word changed. The distribution of the diameters of bolts after the service is still normal with a standard deviation of 0.015. And we're asked to find at the 1% level the critical region for this test, stating your hypotheses clearly. Okay, now first off then, we've got a hypothesis test 1% significance level, and the key word we've got to identify in this question is the fact that it's changed. Now, we haven't been told whether we think it's changed and increased or whether we think it's changed and decreased. So the fact that it just says changed means that this is a two-tailed hypothesis test. So my null hypothesis for this is going to be that the mean is 0.580 as stated. And my alternative hypothesis is going to be that the mean is not 0.580. So it's a two-tailed test at 1%, which means that we're looking for a 0.05 in each tail as our probability. Now, because we're doing a hypothesis test for a sample from a normal distribution, we're going to have to look at the sample distribution here. So D bar for the mean of D follows a normal distribution. The mean will stay the same at 0.58, but the variance will be 0.015 squared divided by 50, because 50 is the sample size. And what I'm just going to do is just write next to that the standard deviation squared, the variance, is equal to 0.015 over 50, which means that the standard deviation is equal to, I'm just going to calculate that as a value. So 0.01 squared, 0.015 squared over 50, and I'm going to find the square root of that, and to 3 significant figures, that is 0.00212. And that's what I'm going to be using for my hypothesis test here. Okay, so what I now need to do is I need to go into my inverse normal function on my calculator. And I need to find the value that gives me an area of 0.005 at each end. So on the ClassWiz calculator, inverse normal is menu 7 and then number 3. So I'm going to start off with an area of 0.005 with a standard deviation of 0.00212 and a mean of 0.58. And the value that it's given me for that is 0.5745. That's at the lower end. And if I come back out of that, I'm now going to change it to 1 minus 0.005, so 0.995, to give me the value at the upper end, which is 0.5855. So what this means is that if I do my test and I get a mean of less than 0.5745, I'd be rejecting the null hypothesis that the mean is 0.580 because it's too low. And if I got a value above 0.5855, I would be rejecting the null hypothesis because that value would be too high, would suggest that the mean is increased. So my critical region for rejection is if the sample mean D is less than 0.5745, or, so I could use the union symbol here, the sample mean is greater than 0.5855. So that's my critical region for the hypothesis test. So whereas in the previous question we were given the outcome, we had to find out the probability that that happened. This time we're being asked, well, what outcomes would be less than 0.5% likely at the lower end and then at the upper end? And we found those two values here. So that's part A complete. Now, part B is telling us that the mean diameter of the sample of 50 bolts is calculated to be 0.587. So I need to compare 0.587 with my values for in the critical region. So if I look at this one here, I've said that if the sample mean comes out greater than 0.5855, then I'd be rejecting H0. So 0.587 is greater than 0.5855, which was my point of rejection in my critical region. So I would be saying at this point, I would be saying that I'd be rejecting H0, and I would be suggesting that there is sufficient evidence that the mean diameter has increased. Because if the distribution has a mean of 0.58 and this standard deviation, it is very unlikely that we would get 0.587 as a diameter. So the fact that this is very unlikely to happen with a less than 0.5% chance means that we have sufficient evidence to reject the null hypothesis that this was the mean and to say we think that the mean might be greater than that because this is so unlikely. So there you go. So that is how to calculate a critical region using a normal hypothesis test. And thank you very much for watching, if indeed you still are.